All right, this is simplifying our sigma notation. So we're going to be using it for is when you have a constant, an I squared, and an I cubed, so our polynomial versions. So if we have our sigma notation, what we end up with is sums. And so wherever there's a sum or a difference, you're allowed to give a sigma through each. So what we're doing is just distributing that sigma. So this would become sigma I squared plus 3I sigma, but 3 is a constant, so we can take it out, and then minus 5. So you're asking, well, why do we get to take the 3 out? Well, let's look at this. So if we have 3I, and we're going to do like 4 of them, right? This would be 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4. You notice they all have a 3, so we could factor out a 3. And so our summation now becomes the sum of I equals 1 to 4 of I. So you can see these 4 become this. So any constant that you have that's multiplied in front, any coefficient, you're allowed to bring outside. And so we end up with this. And now when you have this, you can use these formulas to find them. So our first ones are constant. And if you have a constant, it's like this. If we have I equals 1, let's do 4 again. And you pick some random constant like 5. If I were to plug in 1, I can't, and so I end up with just 5. And then for the 2, I can't, so I end up with 5. And the 3, I can't, and I get a 5. And so then I plug into 4, I get 5. So what this means is I'm going to plug in 1 and get 5, plug in 2 and get 5, plug in 3 and get 5, plug in 4. So I'm going to have literally 4 5s. So I'm going to have 4 sets of 5, which is 20. So when you have a constant here, and there's an n, all you're going to do is multiply them together, just like here, 4 times 5, and that is your sum. So this last one right here is just going to be whatever number it is multiplied. Okay, so when we have this problem right here, this will be the sum of I equals 1 to 20 of I squared plus, and then we take the 3 out, I equals 1 to 20 of I minus the sum of I equals 1 to 20 of 5. And the last one is our constant. And so I can just say, well, that's 20 sets of 5. If I plugged in 1, 2, 3, 4, 5, I'm just going to get 25s. See, this is how we're going to be using to simplify it. Now let's look at the I. The I is the same kind of idea. So I have expanded it over here. So what that means is if I were to plug in 1, I would get 1, and then 2, and then 3, and then 4. This is a summation of all these numbers from 1 to n. So like this. Okay, so let's look at a simpler one. This would be the sum of I equals 1 of I to 100. So I plug in 1, I get 1. I plug in 2, I get 2. I plug in 3, I get 3, and 4, and so on, all the way to 100. Well, there's a way you can look at this as a pattern. If you look at 1 and 100 and you add them together, you get 101. And if you take 2 and 99 and add them together, you get 101. And 3 and 98, you get 101. So if we add the last with the first, I get 101. So what that means is up to 49 and 50, right in that middle, and then 51. These two again would be added to get 101. So if you think about splitting it, right, I have 100 numbers here, right? So 100 divided by 2 sets of 101. So the 100 plus 1 would be 101. The 99 plus 2 would be 101. The 98 plus 3 would be 101. And then I would have a set of 50 of these, half the numbers. And so that's where it's coming from. That's our formula. You see, it's n plus 1 divided by 2. 101, 100 divided by 2. So when you have this, the last number is n, and you're going to add it to the first. So n plus 1, but then you cut it in half, and I would have half of my numbers. And so that's where the formula comes from. It's n over 2, n plus 1. So now you can just plug it in. So my n here is 20. This is n, whatever number's on top. So here, n is equal to 20. And we just plug it in. So it's 20, 20 plus 1, all over 2. And the I squared is very similar. We do the same thing. So this would be 20, 20 plus 1, 2 times 20 plus 1 all over 6. Put a plus in there. I'm going to move that one over a little bit because it's a little too close. And then all we have to do now is simplify. So this is 20, 21, and 41. So 20, 21, 41. And they're all being divided by 6 plus. And then this is 20 and 21. So 3 times 20 times 21 all over 2 minus, and then we can just say that's 100. And then you just keep continuing simplifying. So the 6 has a 2 and a 3, so I can take the 6 and take a 3 out of that, which would make it 7, and a 2 out of that, which would make that 10. So then we do 7 times 41, which is 287, and a 0. So 2870, and we can verify this in the calculator. 10 times 7 288.70. And then the same idea here. This 2 will cancel here, giving me 10. And so we end up with 3 times 21, which is 63, so 630, minus 1,000. And the nice thing about this is if you'd have to do this without these rules, you would be going plug in 1, plug in 2, plug in 3, plug in 4. It'd be a lot of work. But now we can just add these up. So 2870 minus 630 plus 630 minus 100, and you get 3,400. Now there's some shortcuts. We could have just plugged this in our calculator, but let's verify to make sure this is true. So math 0, and then we're going to go from 1 to 20, and it's x squared plus 3x minus 5, hit enter, and look at that, 3,400. So our little shortcut here is all this is. So you can break these apart. Wherever there's a plus or a minus, you distribute the sigma. If there's a coefficient, you take it out. And then you just use our formulas. Each one, plug them in and simplify, and then verify in the calculator, and there you go. This is just practice. You want to get used to practicing these so when you get to calculus, you have the ability to work on them. All right, let's try another one. So again, this would be sum from I equals 1 to 100, and I bring the coefficient out like that. So that's how we'd write our first term. Plus, like that, minus 10. And so we put 2, and then we go back and you look at your formulas. So it's, for I squared, it's n plus 1 to n plus 1. And so the way I remember it is it starts with n plus 1. That's my first number and last number added together, 1 plus n, see, times n over 2, half of them. And so I start the same way here, but what's 2 plus 1? 3, and 3 times 2 is 6. So this would be my third one. So 2 and 1, because it's my also another n plus 1. A lot of patterns here. But the way I remember it again is 2 plus 1 is 3. And so 3 times 2 is 3. So it's n plus 1, and then 2n plus 1. Got it? And then 6. So this would be 100. 100 plus 1. And then 2 times 100 plus 1 all over 6. And then this is 100, and then 100 plus 1 all over 2 minus, and I forgot my summation on the last guy, sum I equals 1 to 100 of 10. And so that last one is just 100 sets of 10. So it's nice and quick. Okay, so now we simplify. This is 2, it's 100, 101, 201, all over 6, plus, and I'm just going to cancel this now, it's 50. So it's 50 times 101 minus 1,000. And then again, that 2 would be 3. And then that 3 goes into 201, 67 times. All right. And then there we go. So if we plug all that in the calculator, we get 100 times 101. I know it says without a calculator, but I'm not doing this by hand right now. 67. So that's 66. 6700. That's nice. 676700 plus, and then this is 5050 minus 1,000. And then we plug it in the calculator, and we get 680750. And check it with the calculator as well, and it says 680750. 680750. So there's our summation. See, it's a lot quicker. Yes, the calculator will do it for us, but this is a nice, quick method to get through it. All right, the last two I want you to try. So same idea. I want you to break it apart just like this, and then simplify. So hit pause now and try. And so there are the answers you should have gotten. So again, the splitting up is 40, and the I inside, and then 100, and then we get 100 sets of 100. And then the I squared and the 4, and we get 1,000 sets of 4. These simplify again to give us this, and they all check perfectly in the calculator. So I hope you can see the benefit of this. Well, this one's 1,000. So you have to plug in 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9, and then 10, and then 11. You get the idea. All the way to 1,000. So look at this. We only got to do 2 different things and use our formulas. So thank you.